Alright, before you start this video, if you don't know the word physics, physics is actually a fundamental experimental science. Or to keep it easy, it's actually science that includes motion, acceleration, velocity, mass, gravity, and all that stuff. For example, riding on a bike is physics. Even standing there it's physics. Crazy, huh? Alright, so here's a video that we made. It's probably one of the cringiest vids you'll ever see. And yeah, go watch it, enjoy it. Peace.
In a world where Donald Trump caused an intergalactic war against aliens. And no, we don't mean Wexicans. Captain Munch and his co-pilot, Wigga, are transporting a cargo back to base.
Suddenly, a bad guy came up from the sky, and it comes toward them. And when they got closer, they started attacking, I guess. The plane went down to pieces. Luckily, the two pilots survived. There on Earth, Captain Munch and the bad guy approach each other. No idea why he's looking on the other side. And they said,
"You little brick, I'm going to kill you."
and the bad guy said,
"It's nerve for nothing!"
Then the war broke out to each other.
Do it again. More.
The bad guy won the fight, and Captain Munch, well, he died. So when the bad guy was having the time of his victory, the lady, or Wigga, came in, and then they started falling in love. Wait, what kind of story is this? Okay, so they basically fall in love, and then boom! Bad guy wins? Wait, seriously? The bad guy wins?
I don't get that.
It doesn't matter.
Dude, it's just supposed to be funny and weird and stupid.
Oh my god, what kind of story is this? Alright, I think that's it of the story. So here's some physics with Alanis.
Now for a quick kinematics lesson using this problem based on the short film. In the short film, Captain Munch and his co-pilot Wigga were transporting some cargo back to their base when they were suddenly attacked. If their plane was 10,000 meters out of the ground, what was their final velocity when their plane got shot down? Hint, use the equation final velocity squared equals initial velocity squared plus 2 times acceleration times final position minus initial position. Now, a quick tip that you want to use before you dive into the problem is to underline what you're given and what you're looking for. Right off the bat, you're given what equation to use and the number 10,000 meters. Now, you're going to want to underline both of those because these are very important to solving this problem. What you're looking for is the final velocity. And now you're probably wondering, how do you know to use this equation? Even if it's given to you, you might still be confused as to how to know if it's correct. Well, let's look at our next step. In the next step, you're going to want to do a little sketch of what's happening in the problem. So, here I drew two boxes, the plane when it's in the air and the plane when it's on the floor. In the bottom left corner here is what you would call the origin. And the origin basically signifies where you're starting from. And you can place it anywhere you want the problem, but I chose to place mine down here because it makes solving this problem a little easier. Now let's see what's shown to us now that we can understand the sketch. So let's start with the origin. Anything that is located at the origin would have to be 0, meaning your initial position is 0 meters and your initial velocity is 0 meters per second. Now your final position would have to be 10,000 meters because in the problem it states that the plane is 10,000 meters to the ground. Final velocity, you don't know, and that's what you're looking for. Your acceleration is 9.8 meters per second squared. And if you're wondering where that number comes from, well, 9.8 meters per second squared is the magnitude of the acceleration due to gravity. And this basically means that for every second an object is in free fall, gravity will cause the velocity of that object to increase 9.8 meters per second. I put an X on it because we don't really need it and it's not given to us. And now back to answering the question, how do you know to use this equation? Well, just make a quick checklist. Do you have the final velocity? Nope, but that's what you're looking for. Do you have an initial velocity? Yep. Do you have the acceleration? Yep. Do you have final position? Yep. Do you have initial position? Yep. So this equation works because you're only missing one thing, and that thing is what you're looking for. Now let's say if this equation had time somewhere in it, it wouldn't work because you'd be missing two things from that equation, so you basically end up with a no solution problem. Now let's get to the solving part. So for solving, just rewrite your equation, see what you're working with. Then you're gonna plug in the numbers, get rid of the 0 because you don't need it, bring down what you have, basic multiplication, and you end up with v2 squared equals 196,000. Now you're still not done because the v2 has that little square on it. So what you're going to want to do is take the square root of both sides to get rid of that little 2. And when you plug in 196,000, the square root of 196,000 into the calculator, you end up with this big sloppy mess. So you're going to want to put that big sloppy mess into scientific notation because you want to keep the right amount of sig-figs. Now, how do you know what's the right amount of sig-figs? Well, look back to the problem. What numbers are you given? You're given the number 10,000. Now, in 10,000, decimal point is at the end, and there's a non-zero number in front of all those zeros, meaning that every number there counts. So let's count. 1, 2, 3, 4, 5. You have 5 sig-figs in 10,000, meaning that you would have to have 5 sig-figs in your answer. Let's count. 1, 2, 3, 4, 5. So this means that this answer works. Now your answer is final velocity equals 4.4272 times 10 to the second meters per second. That's it.
On action.
Oh wait.
Alright, he's there alone and then
He's just celebrating that he killed the guy.
comes in.
Okay.
They're both celebrating.
Okay, now kill him.
Now kill him.
Just jump on him. No.
3, 2, 1, go.
Alright, are all toes accounted for?